Okay, AP Physics. I'm going to go on with part 2 of the Atwood machine answers. We'll start with number 7 here. I'll do a little less talking, and I gave detailed explanations for the first 6 problems, so I'll talk a little bit less on these and move a little faster. Okay, so we're going to do one system. The only mass providing a force downward is the weight of this mass right here. This mass does not contribute to the force going downward, so it's mg. Okay, now the m is both masses. This force has to be able to pull both of these masses, so it's m plus 2m. Okay, so there's the acceleration is 3.3 meters per second squared. Okay, so we only have one tension. This tension and this tension are the same. The pulley doesn't change the tension, it just changes the direction. So we're going to need to write the two equations. Okay, so there's the two equations. We didn't really need to write both of them. If we're going to just go ahead and use this acceleration to figure out t, we could have just stopped there and gone ahead. So 2 times 1 times 3.3 is 6.6. So the tension is 6.6 newtons. Okay, and that's the answer. 3.3 meters per second square, 6.6 newtons. Okay, we're going to use a one system method to find the acceleration as usual. Okay, so the force of these two, mass is 3m plus m is 4m, and g, 4m times g, mass times gravitational, so that's the force. All right, so we're going to go ahead, and there's no friction in this, so we're going to come up here, F equals ma, and the mass is the total mass you see here, so it's 3 plus 1 plus 2 is 6m. Okay, so we simplified it in terms of algebra as far as we can. 2 times 10 is 20, divided by 3 is 6.6. And again, that's meters per second squared. Okay. Okay, now we must use 3 systems in order to determine the tensions. I'll go ahead and do this part in red. So this is T1. It doesn't matter which is T1 and T2, just keep track of it. This is T1 all the way around, and then this is T2 right here. So we'll start with this one. Next is this one. Now you got to remember, same as an earlier problem, it's not only T2 pulling down, not only T2 is pulling down on block M, but its own weight. So that's mg. Those are the positive forces, and the negative is the T1 pulling back in the other direction. This block is going to be, now it's not 4mg anymore, it's 3mg. We're only doing analyzing this particular block, so the weight is 3mg, no longer 4. You're not counting this block anymore. Again, forces on the left side of the equal sign, mass and acceleration on the right side. Okay, so to find T1, the easiest is just to use this formula here. So that's going to be T1 equals 2 times 1 times our acceleration of 6.6. And that's going to equal 13.2 newtons. So there's T1. T2 down here, just have to do a little algebra here. Now subtract this. Place T2 over on the left. Okay, off screen a little, get back on there. Okay, all I did was the algebra step here. Okay, so there you go. So plug in numbers. 3 times 1 times 10 is 30. 3 times 1 times 6.6 is going to be 19.8. Subtract those two and you get roughly 20. So 20 newtons there. And that's that. Okay, made a little math mistake here. 30 minus about 20 is going to be 10 newtons. So let me correct that. So 10 newtons, 13.2, and then the acceleration again was 6.6. Okay, one system first. The only block contributing to the force that's pulling it is this one. Right, so let's go up here. That's the only force. There's no friction in this problem. We come up here. Okay, the only force in this problem is mg. The masses, you take them all together. 3 plus 2 plus 1 is 6. And that equals 10 over 6. So A equals 1.7, 1.66 or 1.7. Either way. Not worrying about the decimals. Okay, you got acceleration. Now we got to write the three equations. Let's start with, we're going to call this T1 and this T2. Again, T2 is all the way down to this block. So let's go ahead and write it for the 3m block. Okay, so T1's pulling it, 3m times the acceleration. The 2m, no friction, so. Okay, and finally this block, the one that actually has a force on it, and that force is mg. Pulling it down in the positive direction, minus T2. Again, T2 goes all the way down to here. All right, so to find T1, we just use this first equation. You got 1.7, 3 times 1 times 1.7 equals 5.1 newtons. Now we'll come down to this one to do T2, and that's going to be T2 equals 8.3. Okay, next problem. Now this one has a friction force, so we got to remember that mu is 0.2. Okay, so the friction force is going to be on this block on the surface of the table. All right, so now we've got to write that into the equation. So now you have two forces. You have the gravity acting on this one and the friction force acting on this one. Okay, so we're going to draw the one body or the one system like this. So this arrow comes out the back, this arrow goes down. All right, so let's go ahead and do that. So F equals ma. The force is, and this is 2mg, the mass times gravitational acceleration. And this is a friction force, so we have to calculate that. This is m. So the weight on this one is mg. Now that's not contributing to it being pulled down, but that's the mg is the weight. So the normal force is the opposite. Since it's a flat surface, it's also mg in the opposite direction. Why? Because if this block is not moving in either of these directions, then the forces have to be balanced. So the normal force, and we'll write that here, Fn equals mg. Therefore, equals mg. Therefore, the friction force equals mu mg. Mu times the normal force. Okay. Let me write that up here. Friction force equals mu times normal force, which is equal to the weight in this case. Not always, but in this case because it's a flat surface. Okay, now we're ready to go. So that is going to be this force right here. All right, so we're going to go ahead, and F is 2mg pulling in the positive direction minus mu mg. Okay, and that equals the total mass in the system, which is 2m plus m is 3m times A. Okay, so now we're going to simplify this equation in variable form. Mg factors out. So you pull mg outside the parentheses, and then you have left here 2, and over here you have mu, 2 minus mu. Okay, you just factored out mg, just basic math, over 3m. The m's cancel. Again, masses cancel, okay? Acceleration of gravity is not is independent of mass. Doesn't matter whether it's big or small mass. Okay, so what we have here then is g times 2 minus mu over 3. So now we're ready to plug in numbers. So it's g is 10. 2 minus 0.2 is 1.8. Just do that on your calculator if you need to. That's over 3. So that's going to be 18 divided by 3, so acceleration equals 6 meters per second squared. Okay, just like that. Okay, now for the multiple systems, so we're going to take this one here, and the force on this way is 2 mg, and we only have one tension, it's T, going all the way around between the two blocks. So it's going to be 2 mg minus T pulling up. And that equals just the mass of this block this time. We're breaking them into two different systems times A. All right. Now at this point, we've done enough problems that you now know you could stop right there. You already know A. You can go and plug A in there and come up with T. But I want you to get practice writing the equations, especially this one. This one's a little trickier. Not really, but... So for this one, you have a tension pulling it in the positive direction, minus the friction force pulling it back. The friction force is mu mg, and that equals ma. Okay. So let's go ahead and use the second. We could use either one to figure out T. Since this one, all we have to do is add mu mg to both sides. Okay, and this cancels over here. So what you have is T equals, and now we're ready to plug in numbers. The acceleration is 6, so 1 times 6 is 6. Plus 1 times 10 is 10 times mu, which is 0.2. So 0.2 times 10 is 2. So that means T equals 8 newtons. Okay, move through this one a little quicker. One system, we have this. We do have a friction force, so again, mu equals 0.2. All right, so we have this force is both of these together. It's 3 plus 2 is 5 mg. All right, now we have to get the friction force coming out the back side. Okay, so this is the only one contributing a friction force. So we'll come down here. We'll say friction force equals mu times normal force. The weight of this one is mg, which means the normal force, since it's on a flat surface, has to be equal and opposite, also mg. So this equals Fn, normal force. So we plug in mu is 0.2 and mg. And actually, let me keep this as mu. I'm going to write it in the general form until we get to the very end. Okay, learn to write in variables. So mu mg is the friction force. Okay, so the forces come over here. F equals ma. The total forces are 5 mg minus mu mg, the friction force. And it equals the total mass, which is 1 plus 2 plus 3 is 6m. A. Now I'm going to solve for A in variable form. Okay, now I can factor out mg just like on the last problem. Five in mu minus mu is left behind in the parentheses. Cancel the m's, and that's what you got. You got G So now we can come down and plug numbers in. G is 10. 5 minus 0.2 is going to be 4.8. 4.8 times 10 is going to be 48 over 6 on the bottom, and that's going to equal 8 meters per second squared for the acceleration. Okay, now we're going to come and break the blocks out into different systems. One there, let's do this in red. One there, and one there. Okay, so this is going to be, we're going to call this T1. This is T1, and then down in between these two, outside of either system, is T2. Okay, so we're going to start with this block up here. The forces are T1 and the friction force going in the other direction. And the friction force is mu times mg. Alright, and that's going to equal the mass of this block, ma. Okay, the next one, this one in the middle. So again, we have two forces pulling down on this one, so let me draw the diagram, and I should have drawn the diagram of this one, so let me do that right here. Okay, this one, let's draw that a little more cleanly here. T2 pulling down on it, plus its own weight pulling down on it, so that's 3 mg. Okay, so the equation would be these two are positive, this one's negative, and mass is 3m and a. Okay, last one is this one. Now it's not being pulled down with 5 mg anymore, it's being pulled down with just 2m. We're only analyzing this block, not the one up above anymore. So it's 2 mg is the downward, so I'm going to cross that out and call it 2 mg when we do the individual systems. And it's being pulled up by T2. Okay, and that equals 2m A. All right, so let's go ahead. We got acceleration right there. So I was a little off screen there. So again, this one was 2 mg pulling down, not 5 mg, because we're only analyzing the weight of this block. Okay, 2 mg down, T2 is pulling it back up, and it's 2 ma. All right, so we're going to find T1. And so what I'm going to do is take this equation. Okay, A is 8, so 1 times 8 is 8, plus m times 1 times 10 is 10, and 0.2 of that is 2. So that means T1 equals 10 newtons. All right. Now we'll bring this equation down here for T2. You know T1, so you could have used this middle equation and plugged T1 and A in, but I'm just going to use the one that just has T2. Draw a line under that. Add T2 to both sides. Subtract 2 ma. So T2 is by itself. I'm going to bring it over here where I have some space. Sorry, I was off on the bottom there, but I was just doing algebra. Okay, hopefully that's okay. 2 mg, I added T2 to both sides, and then I subtracted 2 ma from both sides, so I end up with this. And now we just plug in numbers. 2 times 1 times 10 is 20. 2 times 1 times 8 is 16. So T2 equals 4 newtons. Okay, 4 newtons, 10 newtons, and way up here, 8 meters per second squared. Okay, on to problem 12. So you have a weight here of 3 mg and a weight here of mg, Alright, now it appears that the positive direction should be the direction that the weight is going to be moving, which is this way, the heavier weight, so that's going to be positive, and the other side will be negative. Alright, so treating this as one system, no friction forces involved, it's just gravity. Okay, so come up here, F equals ma. So the forces are this and this. So we're going to say 3m is moving in the positive, 3mg is moving in the positive direction, minus mg, which is moving in the negative direction. It's pulling down against the positive direction. And the two masses together are 4m. Okay, 3mg minus 1mg is 2mg. The m's cancel out as usual. Mass has nothing to do with gravitational acceleration. Okay, and 2 over 4 is 1/2. So we're going to just call this g over 2. That's 1/2, so that cancels and becomes a 2 down there. And that's g on the top still. So that's going to equal 10 over 2, which equals 5 meters per second squared. Okay, so now we're going to write the two equations. So one for this block and one for this block. Again, we're still going to call this the positive direction. So and we're going to call this, there's only one tension. This rope all the way around between the blocks is T. There's no other tension, okay? It stays T all the way around. So we'll go over here, 3mg. And it's 3m mass times acceleration. Now, hopefully you know by now, you could stop right here and just take the 5 and plug it in here and get the t. But let's write both equations to get good at that, okay? So this one is the t is pulling in the positive direction up, over, and to the left, okay? So that's for the m block, it's going to be t minus mg. This mg is pulling down in the negative direction. All right, and that's going to be ma. Okay, and so those are your two equations, and I think the second one's easier. I'm going to add mg to both sides. Okay, there you go. mg is 1 times 10 is 10. ma is 1 times 5 is 5. So t is 5 plus 10. I'll just write it 5 plus, this one's 10. T equals 15 newtons. Okay, do the one system. So this is 3m, this is m. So we're going to say positive is going to be moving this way. 3mg. In the negative direction is mg, but we just call it mg here. Okay. So we're going to come up here, F equals ma. Now we have, yeah, that's it, F equals ma. So the m is 3mg minus mg. And m is 3 plus 2 plus 1 is 6. Okay. All right, we can subtract this and make it 2mg. 3mg minus 1mg is 2mg. Okay, mass always cancels out. 2 over 6 is 1/3 or over 3. So you end up with g over 3. Okay, we're going to draw the diagrams for the blocks. And this is T1 on this side over here, and this is T2 over on this side there. So this is T1. So T1 is pulling in the positive direction because the positive direction goes around this way. Come down here, we'll draw this one. T1's in the positive direction, T2 is pulling it in the negative direction. And then finally this one, get on screen there. This is T2 pulling up on this. So that gives us the third equation of... All right, and so for T1, we're just going to go to this equation. So I'm going to add mg to both sides. Okay, so MA, A is 3.3. So 1 times 3.3 is 3.3, and mg is 1 times 10 is 10. So that means T1 equals 13.3 newtons. Okay, T2, we come down here, add T2 to both sides, subtract. Okay, there you go. So T2 is 3 times 1 times 10 is 30, minus 3 times 1 in acceleration is 3.3, so that's 10. So T2 is going to equal 30 minus 10. T2 is 30 minus 10, which is 20 newtons. We have 20 newtons for T2, 13.3 for T1, and 3.3 is the acceleration. Okay, last problem. So we have 2m, 4m, and 3m. We're going to call this positive since it's going to be pulled in